Yes, this is 300 Plus Academy, where all we do is exams tutoring, ensuring that you ace your next exam. Still on gas laws as far as chemistry is concerned. We'll be looking at Gay-Lussac's law of combining volumes. When we talk about Gay-Lussac's law is primarily concerned with combination of gases. It talks about gaseous reactants and products. So hence we say Gay-Lussac's law of combining volumes. Talking about volumes here, we mean volumes of gases. The law states that when gases combine, they do so in simple ratios of their volume, as you can see on the board. The law states that when gases combine, they do so in volumes which bear a simple ratio to one another, provided that the temperature remains constant. What this is clearly telling us is that when gases combine, we will have normally balanced equation. So according to that equation, according to the mole ratio we have in that equation, so is going to be the distribution in terms of volumes of gases combining in relation to reactants and products. But when we talk about Gay-Lussac's law, the starting point is this. It is about having a balanced equation. And take note again, Gay-Lussac's law is concerned about gaseous reactants and gaseous products. Now, what the law states here is best expressed, of course, when we solve questions. Looking at the first question, it states 70 cm cube of hydrogen were passed into 60 cm cube of chlorine. What that means is that you have hydrogen gas passed into chlorine gas. In this case, for us to have a balanced equation, this is going to be 2 moles of hydrogen chloride gas. So what we basically have here, when you look at the ratio, the mole ratio here is 1 to 2, sorry, 1 to 1 to 2. Of course, we were told, okay, volume available. Volume available, we have 70 cm cube of hydrogen, and then we have 60 cm cube of chlorine gas. Okay, in a hot combustion tube at same temperature, and calculate the volume of the mixture obtained at the end of the reaction. Whenever we've been asked about volume of mixture means volume of the excess reactant plus the volume of the product. Never forget that when we are asked volume of mixture or volume of residual gases, it means the reactant that is in excess plus the product. So in this case, this be the situation. Now let's look at the distribution of things. If I say 70 cm cube of hydrogen is to be used there, it means 1 mole represents 70 cm cube. But when I get to chlorine, this is also 1 mole. And this has to be in volumes which bear simple ratio to one another. So I am saying 70 cm cube to represent 1 mole here. When I look at this, I don't even have up to 70. So I cannot say 70 here. So that means this is wrong. I'd have to start from here. This is looking more like a limiting reactant. So 60 cm cube. If I say 1 mole to represent 60 cm cube, it means here 60 cm cube would have been used up. Okay, what was in excess? Excess here is 10 cm cube of hydrogen, because of course what was used is here was 60. What I have was 70. 70 minus 60, 10. Nothing was in excess here. When I talk about the products here is, since this is 2 mole, then this is going to be 120 cm cube. That is the volume of the product. If the question here had asked me what is the volume of the product, I would have just said 120 cm cube. If the question here had asked me what is the volume of the excess hydrogen, I would have said 10. But the volume here says what is the volume of the mixture obtained after reaction. The volume obtained after reaction here is what is in excess plus the product, and in this case that is 130 cm cube. So that ends question 1. But take note, for some of you, you think it just merely means 70 cm cube plus 60 cm cube. No, it doesn't work that way. It's just a coincidence that, okay, 70 plus 60 is giving us 130 here. No, there are instances, not there are instances, in subsequent questions, you see that when you try to add up the reactants, you will never get the answer. So it's something totally different. It's not just by sheer addition of whatever figures you're seeing in the question. The starting point is you must be able to write a balanced equation, and then from a balanced equation, you then proceed looking at the mole ratio, looking at what is available, looking at what is used in simple ratios to their volume, looking at what is in excess, and of course, you determine what will be the volume of your product. That is how to proceed as far as Gay-Lussac's law is concerned. Moving on, the second question states 50 cm cube of carbon dioxide were formed when red hot coke. Red hot coke here means carbon. 50 cm cube of carbon dioxide were formed when red hot coke, that's carbon, is burnt in excess oxygen. So what this means is carbon, which is a solid. Of course, this cannot be involved because it is not a gas. Combines with excess oxygen so that we have CO2 gas. Oxygen here is also a gas. So we were told here that 50 cm cube of carbon dioxide were formed. So looking at, this is the balanced equation. Looking at the mole here, we're not even going to be concerned about this. So it's 1 to 1. So if you tell me that the product formed here is 50 cm cube. Of course, the product here is 1 mole. Then the question I'm being asked is calculate the volume of oxygen used up. Okay, volume of oxygen used up here. This is the oxygen. Volume used. If 1 mole represents 50, then the volume of oxygen used up is also going to be 50 cm cube. And that is the answer. So if 1 mole represents 50, then 1 mole here is also going to represent 50, telling you that, look, Gay-Lussac's law is always consistent once you have a balanced equation. So the answer to this question 2 is actually 50 cm cube. Moving on to the third question, it says calculate the volume of product formed when the total volume of residual, calculate the volume of product formed and the total volume of residual gases when 90 cm cube of sulfur 4 oxide gas is allowed to react with 140 cm cube of oxygen. Of course, when sulfur 4 oxide gas, SO2 gas, is allowed to react with oxygen gas, you need to know we're going to have sulfur 6 oxide gas, SO3 gas. So the next thing is to try to balance this. This is SO3. I can look at it this way, okay? Then if I put 2 here, okay? If I put 2 here, then I think it's balanced this way. Now, this is a balanced equation for the reaction between sulfur 6 oxide and oxygen gas. So in the question, okay, let's look at it. Talking about the mole ratio here is 2 to 1 to 2. We were told, okay, volume available is for SO2, we have 90 cm cube of this available. And then for oxygen, we have 140 cm cube. 140 cm cube available. Okay, so having said this, let's look at what is going to be used up. If I should say, for example, 140 cm cube of oxygen is being used up. Look at it. It means 1 mole here represents 140 cm cube. So for me to have 2 mole here, I'll need 140 cm cube times 2. That's 280. But I don't have up to 280, so I cannot go this way. But if I say, okay, for these 2 moles of sulfur 4 oxide gas, let 90 cm cube be used up. That means 1 mole equals 45 cm cube. That's what it means. So that when I come here, since oxygen is 1 mole here, it is 45 cm cube that will be used invariably. So I then talk of what is in excess. Nothing is in excess here, but for this, what's in excess is 95 cm cube of oxygen. And then when you talk about your products, since this is 2 moles, your product is also going to be 90 cm cube. That is the volume of sulfur 6 oxide. From now, the question states this: calculate the volume of the product from. When you talk about volume of the products, volume of the product here is 90 cm cube, and that is for sulfur 6 oxide. And then the other side of the question says, and the total volume of residual gas. When you're being asked volume of residual gas, it is the volume of the excess reactant plus the volume of your products. In this case, volume of my excess is 95 cm cube plus that of the product 90 cm cube, and that's going to give me 185 cm cube. That is the answer. And that is to tell you, you see what I was saying, if you decide to add 140 plus 90, that will give you 230. 230 will be in the option. So if you decide to subtract 140 minus 90, 50 will be in the option. If you decide to add together and divide by 2, 115 cm cube will be in the option. So it is not this way. The starting point when dealing with Gay-Lussac's law is that you have to be able to write your balanced equation and work things out according to their mole ratio, and that way you're going to get your answer. So the answer here is 185 cm cube. So that ends question 3. For question 4, it says a mixture of 100 cm cube of sulfur 4 oxide and 150 cm cube of oxygen. This is still about sulfur 4 oxide gas and oxygen gas in this case. Okay, sulfur 4 oxide and oxygen gas. It's going to form SO3 gas in this case. So in a bit to balance, this will be 2 and this will be 2. This is a balanced equation. So the mole ratio is still 2 to 1 to 2. We were told that a mixture of 100 cm cube of SO2. So mole ratio is 2 to 1 to 2. What is available here? SO2 here is 100 cm cube. And then oxygen here is 150 cm cube. Okay. So when you look at it, what is being used up here is the next thing. So when I look at this, if I say 2 moles, okay, let the 100 cm cube here be used up. Since this is 1 mole, it means it is only 50 cm cube that will be used up. That is the implication. So what that means is that excess, we don't have excess here, but for this 100 cm cube is in excess. And when you talk about your products, your product is 100 cm cube as well. So when you look at the question says calculate the amount of excess oxygen left unused. Excess volume of oxygen that's in excess that's left unused, that is 100 cm cube. And then the last part of the question says composition of the mixture. So when you're being asked composition of the mixture, it is still like asking you for the volume of the residual gas, that is SS plus products. In this case, 100 cm cube plus 100 cm cube, making 200 cm cube. That is the answer. So you can see by adding 150 and the 100 here, it's not going to give you 200. So normally in the options, you may have 200 cm cube. This is going to be wrong. You may have 150 minus 100 for the lazy student, that's 50. You'll still be wrong. Some will add the two together. 150 plus 100, you'll still be wrong. 250 cm cube. Some will add 250 and divide by 2, telling you they are looking for the average. 125 cm cube. You still will be wrong. So there is nothing you can do other than for you to get your balanced equation and flow without things being done in the proper way. And that way you get the right answer. So let's move on to another set of questions talking about substances reacting with air. And when substances react with air, it is going to be the oxygen component of air that substances will react with. Substances will not react with other components of air like nitrogen, the noble gases, or the carbon dioxide. So we're going to look at Gay-Lussac's law that involves substances reacting with air now. Moving on to question 5, as you can see here, normally when we talk about air, let me quickly say this here. When we talk about air, it contains oxygen, it contains nitrogen, you're talking carbon dioxide, you're talking the noble gases. Oxygen is 21%, nitrogen is about 78%, and the rest, that's okay, you have water vapor there. The rest components makes up for about 1%. So we need to take note of that. So in this question, it says 10 cm cube of carbon dioxide, as carbon monoxide, is packed with 100 cm cube of air. So what we have here is CO, that's a gas, packed with air. Okay. Containing 21% oxygen. Calculate the volume of the residual gas. First, you need to know that carbon monoxide is not going to react with this air. It is going to react only with the what? Oxygen component of air. So when you look at the air that we have here, we have 100 cm cube of this, 100 cm cube of air. So if I say the oxygen component here is 21% of that 100 cm cube, so that's going to mean the oxygen I have here is 21 cm cube, and this is what will go into the reaction. So if I say then I need to talk about unreacted air. Unreacted air is going to be, I have 100 cm cube minus 21 cm cube, which represent the oxygen component that will go into the reaction. So I'm going to be left with 79 cm cube air. Take note of this. Okay, let this stand this way. So that what this means is that I have CO gas to react with oxygen gas, so that CO2 gas is formed in this case. So in order to balance this is looking 2, and then if I put 2 here, of course this look balanced. So I'm going to just go, the mole ratio here is 2 to 1 to 2. And when I look at my carbon dioxide, what is available? What is available here is 10 cm cube of CO, 10 cm cube. And what is available in terms of oxygen is 21 cm cube. So what was being used here is going to be, if 2 moles represent 10 cm cube, if I say 10 cm cube is being used there, since this is 1 mole, it means only 5 cm cube of the oxygen component will be used, and the SS is going to be nothing here, and this is going to be 16 cm cube of oxygen will be left unused. I'm talking about the products. The product in this case is going to be, of course, 10 cm cube, because this is 2 moles, 10 cm cube. So in the question, we're told to calculate the volume of the residual gases. The volume of the residual gases here is actually, looking at where we started from, we have unreacted air here, unreacted air plus SS oxygen plus that the volume of the product formed. So when you look at all of this, this is 79. This here is 79 plus excess oxygen here is 16, and the product here is 10. Everything equals 105 cm cube. 105 cm cube. So when you look at it, 100 is what you have in the question for air, 10 cm cube for CO. So you would understand that this is not about just adding together and dividing or subtracting. No, you're never going to get or make any headway that way. No. So you just have to flow with things. We have unreacted air, then we move into Gay-Lussac's proper. We look at the SS, we look at the product, we take that together. That is the volume of the residual gases left after the whole of the reaction here. So the answer to this question is 105, talking about question 5. Okay, moving on to the next question, question 6, also talking about air. Now 50 cm cube of hydrogen were exploded with 80 cm cube of air. So we basically have hydrogen gas and it was exploded with air. Just like the last question, the hydrogen here is going to be reacting with the oxygen component of air. So this air is 80 cm cube. So since hydrogen will be reacting with the oxygen component, without being told, oxygen is 21% of air. So that's 21% of 80 cm cube. So the volume of oxygen going into the reaction here is 16.8 cm cube. So we can then bring this down. Okay, you're looking at hydrogen gas reacting with oxygen gas. In this case, you're looking at H2O gas, that's steam being formed, and in a way to balance this, this is what we are going to have, so that the mole ratio here is 2 to 1 to 2. But don't forget, unreacted air component is going to be 80 minus 16.8. So 80, because 80 cm cube is the volume of the air, and this is the component of oxygen that goes into the reaction. So this is going to give us 63.2 cm cube of air. We'll keep that aside. So moving on with the main question for Gay-Lussac here. So what was available? Available here, hydrogen here is going to be 50 cm cube, and then oxygen here, I'm going to be using the 16.8 cm cube that I have here. So you look at what is being used up. This is 2 moles. This is 2 moles. If I should say 50 cm cube is being used up, then what it means is that this is 1 mole. I'll need 25 cm cube. But look at it. I have 16 cm cube of oxygen, 16.8 cm cube of oxygen available. So I cannot use up to 25. So this is all shades of wrong. So what it means is that this is 16.8 cm cube. Now it means that for every 1 mole, that means 16.8. So for this means 16.8 times 2, and that is 33.6 cm cube. So that's that about that. So what is in SS? What do I have in SS? 50 minus 33.3. This here is going to give me 16.4 cm cube. That's what is in SS. Nothing is in SS here. Nothing is in SS here. So talking about the product here is going to be 2 moles. So that is 33.6 as well. 33.6 cm cube. So these are the things that matters now. What is in SS, and then the product. In this case, the whole of the oxygen is being used up. So we were told to calculate the composition of the resulting gas. In this case, the composition is what we have the unreacted air plus what we have in SS hydrogen plus the product that we have in here. So this is 63.2 plus 16.4 plus 33.6. So when we take all this together, this is going to give us 103.2 cm cube. This is our answer, 113.2 cm cube. That is the composition of the resulting gas. And with that, we've come to the end of Gay-Lussac. Don't forget, for you to ace your next exam, this is where you need to be. It is 300 plus. Hit the subscription button, turn on the notification bell, and do well to share with your friend. From myself and the entire team, it's bye for now.